It's important to understand why T-strippers and levels are essential tools in electrical work. Firstly, let's address T-strippers. Properly designed T-strippers, when used correctly, do not nick wires. They are designed to cleanly remove insulation from wires, exposing the conductor for proper connections. These tools have calibrated notches that match specific wire gauges, ensuring the blade only cuts through the insulation without damaging the underlying conductor. Using a knife or other sharp objects to strip wires can damage the insulation and conductor, leading to potential electrical hazards. When using a knife, it's easy to accidentally cut too deep, creating a weak point in the wire that can break or cause a short circuit. T-strippers offer a consistent and controlled stripping action, minimizing the risk of damage. It's crucial to select the correct gauge setting on the T-stripper to match the wire size. Using a setting that's too small can damage the wire, while a setting that's too large may not remove the insulation completely. Always inspect the stripped wire for any signs of nicks or damage before making a connection. If damage is present, cut off the damaged section and restrip the wire. Different types of T-strippers are available, including manual, automatic, and coaxial cable strippers. Manual strippers require the user to squeeze the handles to close the blades and strip the insulation. Automatic strippers have a spring-loaded mechanism that strips the insulation with a single squeeze. Coaxial cable strippers are designed for removing the outer jacket and dielectric insulation from coaxial cables. Regular maintenance of T-strippers is essential to ensure their proper functioning. Clean the blades regularly with a wire brush to remove any debris or corrosion. Lubricate the moving parts with a light oil to prevent sticking. Replace the blades if they become dull or damaged. When working with electrical wires, always follow safety precautions. Wear appropriate personal protective equipment, such as safety glasses and gloves, to energize the circuit before stripping wires to prevent electric shock. Work in a well-lit and ventilated area to avoid accidents. Always double-check the wire gauge before selecting the appropriate setting on the T-stripper. Ensure the wire is fully inserted into the stripping notch before squeezing the handles. Avoid using excessive force when stripping wires, as this can damage the conductor. Dispose of stripped insulation properly to prevent environmental contamination. Always use a UL-listed T-stripper that meets industry standards. Now let's discuss levels. Levels are crucial for ensuring that electrical fixtures, boxes, and switches are installed level and plumb. Installing uneven fixtures can result in aesthetic issues, improper operation, and potential safety concerns. A level uses a bubble in a liquid-filled vial to indicate whether a surface is perfectly horizontal or vertical. The bubble should be centered between the two lines on the vial for a true reading. Levels come in various sizes and types, including spirit levels, laser levels, and digital levels. Spirit levels are the most common type and are suitable for general-purpose applications. Laser levels project a beam of light to create a level plane, making them ideal for aligning objects over long distances. Digital levels use electronic sensors to measure angles and display the results on a screen. When installing electrical fixtures, use a level to ensure that the fixture is mounted straight and aligned with the surrounding surfaces. For example, when installing a light fixture on a ceiling, use a level to ensure that the mounting bracket is perfectly horizontal. When installing a wall-mounted outlet or switch, use a level to ensure that the device is plumb and aligned with other devices in the same gang box. Ignoring the use of a level can compromise the quality and safety of the electrical installation. Uneven fixtures can create a tripping hazard, especially in areas with low lighting. Misaligned switches and outlets can be difficult to operate and may not make proper contact with plugs. In addition to aesthetic and operational concerns, uneven fixtures can also indicate underlying structural problems. For example, a wall that is not plumb may be a sign of foundation issues or settling. When installing electrical boxes, use a level to ensure that the box is flush with the wall surface. A box that is not flush can create a gap between the device and the wall, allowing dust and debris to enter the electrical system. This can also create a fire hazard if the wires inside the box come into contact with flammable materials. When installing conduit, use a level to ensure that the conduit runs straight and level. Uneven conduit can create obstructions and make it difficult to pull wires through the conduit. It can also create a tripping hazard if the conduit is exposed. Always use a level in conjunction with other measuring tools such as a tape measure and a square. This will help you ensure that the electrical installation is accurate and precise. When using a level, always check the calibration of the level before using it. To check the calibration, place the level on a flat surface and note the position of the bubble. Then, rotate the level 180 degrees and check the position of the bubble again. If the bubble is in the same position in both orientations, the level is properly calibrated. If the bubble is not in the same position, the level needs to be adjusted. Store levels in a safe place to prevent damage. Avoid dropping or bumping levels, as this can affect their accuracy. Clean levels regularly with a soft cloth to remove dust and debris. When working with electricity, always follow safety precautions. To energize the circuit before working on any electrical component. Wear appropriate personal protective equipment, such as safety glasses and gloves. Work in a well-lit and ventilated area to avoid accidents. Always double-check your work to ensure that everything is installed correctly. Consider the contractor's claims and actions regarding T-strippers and levels indicate a lack of understanding of proper electrical practices and a disregard for safety. Such attitudes can create a hazardous work environment and compromise the reliability and safety of electrical installations. It is important to work with electrical contractors who prioritize safety, follow established standards, and use appropriate tools for the job. Ignoring fundamental tools and techniques can lead to code violations and potentially dangerous situations. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including requirements for the proper use of tools and materials. Violating the NEC can result in fines, penalties, and even legal action. Here are some specific NEC sections that relate to the use of tools and materials in electrical work. NEC Section 110.3b requires that all electrical equipment be installed and used in accordance with the manufacturer's instructions. This includes using the correct tools for the job and following the manufacturer's recommendations for stripping wires and installing fixtures. NEC Section 110.12 requires that all electrical work be performed in a neat and workmanlike manner. This means that the work should be done carefully and accurately, using appropriate tools and techniques. NEC Section 300.4f requires that cables and raceways be protected from physical damage. This includes using appropriate tools and techniques to avoid damaging the insulation on wires and cables. When selecting electrical tools, always choose high-quality tools that are designed for the specific task at hand. Avoid using cheap or poorly made tools, as these can be dangerous and may not perform the job correctly. Invest in a good set of T-strippers, a level, a tape measure, a square, and other essential electrical tools. Take care of your tools and maintain them properly. Clean them regularly, lubricate them as needed, and store them in a safe place. By using the right tools and techniques, you can ensure that your electrical work is safe, reliable, and code compliant. Remember that electrical work can be dangerous, so it's important to follow all safety precautions and consult with a qualified electrician if you have any questions. Proper electrical work relies on understanding and adhering to several key concepts. Firstly, grounding and bonding are critical for safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of shock. Secondly, overcurrent protection devices, such as circuit breakers and fuses, protect the electrical system from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Thirdly, wiring methods must comply with the NEC and local codes. Common wiring methods include conduit, cable, and raceway. Each wiring method has its own set of requirements for installation and support. Fourthly, box fill calculations are necessary to ensure that electrical boxes are not overcrowded. Overcrowded boxes can create a fire hazard and make it difficult to work on the electrical system. The NEC provides guidelines for calculating the maximum number of wires and devices that can be installed in a box. Fifthly, voltage drop must be considered when designing electrical circuits. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. The NEC provides guidelines for calculating voltage drop and selecting the appropriate conductor size. Sixthly, conductor ampacity is the maximum amount of current that a conductor can safely carry. The NEC provides ampacity tables for different types of conductors based on their size, insulation, and installation method. It's important to select conductors with sufficient ampacity to handle the expected load. Seventhly, proper labeling and identification of electrical circuits and equipment are essential for safety and maintenance. Circuits should be labeled with their purpose, voltage, and amperage. Equipment should be labeled with its voltage, amperage, and other important information. Eighthly, regular inspection and maintenance of electrical systems are necessary to ensure their continued safety and reliability. Inspection should be performed by qualified electricians and should include a thorough examination of all electrical components. Maintenance should include cleaning, tightening connections, and replacing worn or damaged parts. Ninthly, understanding electrical diagrams and schematics is crucial for troubleshooting and repairing electrical systems. Diagrams and schematics provide a visual representation of the electrical system, showing the connections between different components. Tenthly, safety is paramount when working with electricity. Always de-energize circuits before working on them, wear appropriate personal protective equipment, and follow all safety precautions. If you are not comfortable working with electricity, consult with a qualified electrician. Knowing common electrical symbols is important for interpreting electrical drawings and schematics. Some common symbols include those for resistors, capacitors, inductors, diodes, transistors, switches, and fuses. Each symbol represents a specific electrical component and its function in the circuit. Understanding these symbols allows you to trace the flow of current and understand how the circuit operates. Common electrical formulas are used to calculate voltage, current, resistance, and power. Ohm's law states that voltage is equal to current times resistance, or voltage equals current times resistance. Power is equal to voltage times current, or power equals voltage times current. These formulas are essential for designing and troubleshooting electrical circuits. Different types of electrical testers are available for measuring voltage, current, resistance, and continuity. A multimeter is a versatile tool that can measure all of these parameters. A clamp meter is used to measure current without breaking the circuit. A continuity tester is used to check for broken wires or open circuits. Understanding the proper use of these testers is essential for troubleshooting electrical problems. Electrical codes and standards are established to ensure the safety and reliability of electrical systems. The NEC is the most widely used electrical code in the United States. Other codes and standards may be applicable depending on the location and type of electrical installation. Adhering to these codes and standards is essential for ensuring the safety of people and property. Electrical safety procedures should always be followed when working with electricity. These procedures include de-energizing circuits before working on them, wearing appropriate personal protective equipment, and using insulated tools. It's also important to be aware of potential hazards such as exposed wires and wet conditions. Following these procedures can help prevent electrical shock and other injuries. Troubleshooting electrical problems requires a systematic approach. Start by identifying the symptoms of the problem. Then, use electrical testers to measure voltage, current, and resistance to identify the source of the problem. Consult electrical diagrams and schematics to understand the circuit and how it operates. Finally, use your knowledge of electrical principles to diagnose the problem and implement a solution. Regular electrical maintenance can help prevent problems and extend the life of electrical equipment. This includes cleaning electrical components, tightening connections, and replacing worn or damaged parts. It's also important to inspect electrical systems regularly for signs of damage or deterioration. Performing regular maintenance can help ensure the safety and reliability of electrical systems. Electrical energy efficiency is becoming increasingly important as energy costs rise and environmental concerns grow. There are many ways to improve electrical energy efficiency, such as using energy-efficient lighting, installing programmable thermostats, and reducing standby power consumption. Implementing these measures can save money and reduce your carbon footprint. Renewable energy sources, such as solar and wind power, are becoming increasingly popular as a way to generate electricity. These sources are clean, sustainable, and can help reduce our reliance on fossil fuels. Solar panels convert sunlight into electricity, while wind turbines convert wind energy into electricity. Using renewable energy sources can help reduce your environmental impact and save money on your electricity bill. Smart grid technologies are being developed to improve the efficiency and reliability of electrical grids. These technologies include smart meters, advanced sensors, and communication networks. Smart grids can help reduce energy consumption, improve grid stability, and enable the integration of renewable energy sources. Understanding these concepts is essential for anyone working with electricity, from homeowners to electricians to engineers. By following these guidelines, you can ensure that your electrical work is safe, reliable, and code compliant. Remember that electricity can be dangerous, so it's important to always follow safety precautions and consult with a qualified electrician if you have any questions.